Hello, and welcome to the video on tests for cyclic quadrilaterals. In this video we will discuss how to prove if points are concyclic, which means that they are all in a circle. So how do you tell if a quadrilateral is cyclic? The last theorem we discussed stated that if a quadrilateral is cyclic, then the opposite angles have to be supplementary. Well, the converse is a test for the cyclic quadrilaterals, and that is, if the opposite angles of a quadrilateral add up to 180, then we know that the shape has to be cyclic. So let's prove it. Our aim is to prove that the quadrilateral KLMN is cyclic. We know that KLMN is a quadrilateral and that angle KLM and angle KNM add up to 180. To help with our proof, we'll join KM, which is between KL and KN. We'll also draw a circle which will pass through KL and N. We'll suppose that the circle doesn't go through M for the moment, and if it doesn't go through M, then it has to cut the line KM somewhere along the line at P. We're going to join LP and NP together to go with our other constructions. Now, by construction we can see that KLPN is a cyclic quadrilateral because all the vertices go on the circle. So KLP and KNP equal 180 degrees because the opposite angles of a cyclic quadrilateral are supplementary. But we know that angle KLM and angle KNM are also 180 from our data. That's how we started drawing our quadrilateral. Therefore, angle KLP plus angle KNP equals KLM plus KNM. And that's because both add up to 180 degrees. But this is impossible. The angles KLP and KNP have to be bigger than the angles KLM and KNM respectively. Therefore, we can say that the circle passing through KL and N also has to pass through M, which means that KLMN is a cyclic quadrilateral. Let's look at example 13. In triangle ABC, AF is perpendicular to BC and BD is perpendicular to AC. We're going to prove that CDEF is a cyclic quadrilateral. Pause the video and see how you might be able to prove that the quadrilateral is cyclic. Think about the test we just examined and how to show a quadrilateral is cyclic. Okay, we want to prove that CDEF is a cyclic quadrilateral. We know AF is perpendicular to BC and BD is perpendicular to AC. We begin our proof by stating that angle AFC has to be 90 degrees because AF is perpendicular to BC. Similarly, angle BDC also equals 90 degrees because BD is perpendicular to AC. Therefore, angle AFC plus angle BDC adds to 180. But these two angles are opposite angles in a quadrilateral. Therefore, CDEF is cyclic because a quadrilateral with a pair of opposite supplementary angles has to be cyclic. Another test for concyclic points relates to angles in the same segment. It says, if an interval subtends equal angles at 2 points on the same side of the interval, it is important that they're on the same side and not opposite sides, then the 2 points and the endpoints of the interval are concyclic. Let's look at a proof at why this is so. We want to prove that A, B, D, and C are concyclic. We know C and D are points on the same side of A and B, so that angle ACB and angle ADB are equal to each other. This is what we want to prove. If these two angles, which would be in the same segment, are equal to each other, then the quadrilateral has to be cyclic. We'll draw in a circle passing through A, B, and C, but we're going to assume that it doesn't go through D, but it cuts the line at X, and then we'll join BX. Now by construction we can see that ACX and B are concyclic points. This means that angle ACB has to equal angle AXB, because they are angles in the same segment. But angle ACB equals angle ADB from our data. This means that angle AXB equals angle ADB, because they are supposedly both equal to ACB. Now, in our triangle BXD, angle AXB will equal angle XDB plus angle DBX. Why? Because it is the exterior angle of the triangle which is equal to the opposite two interior angles. Now, this is only possible if angle DBX is 0, because angle AXB is supposed to equal angle ADB. And this means that D and X must be the same point, which means that D is on the same circle as X, making A, B, D, and C concyclic points. We will look at example 14 to use our next test. PQ and RS are two lines that intersect at T. If angle RPT equals 44 degrees, and angle RTP equals 96 degrees, and angle TQS equals 40 degrees, we are to prove that P, R, Q, and S are concyclic. At this point, pause the video and try to see, using our latest test, why these points would be considered concyclic. Okay, our aim is to prove that PR, Q, and S are concyclic. We know that PQ and RS are two lines that intersect at T, and we know the values of RPT, RTP, and TQS. I can see straight away that angle PRT equals 40 degrees, and this is because the angle sum of a triangle, PRT, is 180. Therefore, angle PRS and angle PQS are equal to each other as they are both 40 degrees. But these are a pair of angles on the same side of PS. This means that PR, Q, and S have to be concyclic. Easy proof? The next video will be on the relationship between angles in the alternate segments. Thanks for watching.